Tell me how it is, Mayor.
I promise I'll tell. Hit it!
Disease is Parkinson's. Parkinson's, the 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 disease is Parkinson's. Low dopamine is bad. It leads to the loss of brain cells, yeah.
Oh!
A symptom is, muscle rigidity. It compromises the ability to move,
Zoe Maxwell, we're ready for you. Hi, I'm Dr. Mary. So what brings you here today?
Hi, I know something's off. I've been having tremors. I can't, and my balance is just completely off.
Okay, well, we'll check it out.
Thank you.
It seems as if you have a case of Parkinson's disease. I'm so sorry.
What does that mean exactly?
It's a neurodegenerative disorder that prohibits the production of dopamine, which leads to an overall decline in brain activity. And that would explain the symptoms you were experiencing.
So, how does this happen?
So let me talk you through the cell signaling pathway. The order of pathway follows as the signal mechanism, the receptor, transduction, and cellular response. The G protein system, which is the transduction pathway, is affected by Parkinson's disease. In step 1, a signal molecule, which is called the ligand, binds to the G protein receptor. In step 2, the G protein becomes active if GTP is bound to the receptor, and the G protein becomes inactive if GDP is bound to the receptor. The activated G protein binds to an enzyme in order to carry out a cellular response, and that's the cell signaling pathway.
Okay, so dopamine is a neurotransmitter, right?
Yes.
So that means when enough dopamine is created, signals can be sent from nerve cell to nerve cell.
Exactly.
And are there 2 receptors?
There are.
Okay, so in the first receptor, signaling can occur through G proteins to activate adenylate cyclase.
Yeah.
And then that causes an enzyme to form, and PKA can be activated?
Exactly.
Okay. So that means in the second receptor, there's a signaling that's blocked?
Yeah.
So that means that by inhibiting adenylate cyclase, the whole entire signal is blocked?
Exactly.
Okay.
Yes, exactly, but in your case, we're actually dealing with a rare faulty mechanism. And in this mechanism, the protein PINK1 in the mitochondria protects the cell from oxidative stress and regulates the protein TRAP1. Oxidative stress is a damage caused to cells by the production of reactive oxygen through the metabolism of oxygen. Genetic mutations of the protein PINK1 and DJ1 leads to mitochondrial dysfunction and accumulation of reactive oxidative species. When the mitochondria malfunctions, there's an abundance of cytokines, which become Lewy bodies, which are abnormal aggregates of protein that block the creation of dopamine.
Wow. Okay.
So Zoe, there's a correlation between calcium channels and Parkinson's disease. Calcium channels are ion channels, which are membrane proteins that allow for the flow of calcium ions in response to the depolarization of the membrane. There are several types of calcium channels that are either ligand-gated or voltage-gated, and they perform specialized functions.
Oh wait, I actually read an article recently that said that scientists have speculated that the denaturing of dopamine-producing neurons may be due to their increased dependency on calcium channels, right?
That's exactly right. As humans age, the neurons begin to age as well, leading to a struggle to keep up metabolic activity.
So that means that the increasing reliance on calcium channels can lead to mitochondrial distress,
Yes.
which increases the likelihood of cellular aging and eventual death.
Exactly. I'm so sorry.
So what do I do now?
I can write you a prescription to help with any sort of pain you're experiencing or even to help with some of the symptoms. And you can just go to your local pharmacy and pick it up.
Okay, thank you.
Bye, Zoe.
So unfortunately, there's no cure for Parkinson's disease. However, there are new medications and treatments to slow the progression down.
For example, there are pharmacological approaches, gene therapy, deep brain stimulation, and cell implantation.
There's a new drug called levodopa, which allows nerve cells to create more dopamine to replenish the brain's reduced supply.
Thanks for watching! Hope you enjoyed our project!